A mapping is a transformation taking the points of one space into the points of another space. So for example, if I have some points on a coordinate plane, and I call this point point A, and I map it onto point A prime, that means I just move it onto another space. A congruence transformation is exactly what it sounds like. It's a transformation that occurs that leaves the original image exactly the same size and shape. The original image is called the pre-image, and it doesn't change the size and shape of it. A similarity transformation, also known as a dilation, is a transformation that changes the size of a pre-image by a common scale factor. As I said, the pre-image is your original figure, and we just call the pre-image a capital letter. So if I plot a point and this is my original figure, A would be how I would name it. When we do something to the pre-image, it's called an image. It's the resulting figure after a transformation has taken place. We name it with it's called A prime, B prime. It's an apostrophe, but it's called a prime, following the capital letter. So if I move A over to the left, I denote that it's been moved by calling it A prime. So A is my pre-image, and A prime is my resulting image. The transformations that we're going to be dealing with are described in terms of coordinates. So you got your x and y coordinates, and we name them by a capital letter. And the symbol we use to indicate that a mapping has occurred is the arrow. And for example, we would say M, that's my capital letter, says the transformation M maps x and y to 2x, y. So all this says is that a transformation has occurred, and here's my original coordinates, and it'll always be that. X, y will always be your original coordinates. And then this is what happened to my original coordinates. I multiplied my x values by 2. That's all it says. Okay, a word that you're going to hear a lot is an isometry. An isometry moves the pre-image, remember that's your original image, one time, whether it rotates it, translates it, reflects it. And then as a result of that movement, you get a congruence transformation. So the image that has resulted is exactly the same size and shape as the pre-image. So for example, if I have a heart, and this is going to be kind of sloppy, but if I have a heart and I reflect it, let's say I did that evenly, over this line, this would be the same size as this. That would mean it's a pre-image, or it's an isometry. Okay, so now let's actually utilize some of this vocabulary. First, we're going to plot the original points, the pre-image points. And then we're going to perform the transformation T as it maps x and y to 2x and y. So basically that means we take our original xy coordinates and we multiply the x value by 2, and we just leave the y value alone. So let's start by graphing our pre-image. M is 0, 0, and n is 3, 0. Oops, we don't want that. So let's go ahead and transform it by multiplying our x value by 2, and 2 times 0 is 0, and we leave our y value alone. The next one, we multiply our x value by 2, as it says to do here, and that's 6, and we leave our y value alone. So our resulting image of M prime is still at 0, 0. So we can name this M prime. And N, as the pre-image, becomes N prime, the image, at 6, 0. So this was 3, 0, so we want to move over 3. And this is N prime. A reflection is an isometry. Remember, an isometry is a congruence transformation, meaning whenever we move it, it results in the same shape and size. So whenever we move the pre-image, it's the same shape and size as the image. And a reflection uses a line that acts like a mirror. So let's say this is our line of symmetry. The line of symmetry is the line that you reflect an object over. And let's say that we want to reflect this rectangle over this line. So that means that the rectangle, if we want to reflect it, it's the same thing as flipping it over the line. It needs to be the same distance away from the line, but on the other side. And I know this is a bad picture, but the pre-image should be exactly the same size as the image. Okay, so in this first example, I'd like for you to reflect the points V through Z in the line y equals y. So remember the line y equals y. If this is my y-axis, my vertical axis, I graph the line y equals y. So I find, y equals 1. So I find 1 on the y-axis and I draw a straight line horizontal. So that is the line y equals 1. Now, I'm going to reflect the points V through Z over the line y equals 1. So that just means that for each point, I have to figure out how far away it is from the line and then make the image that much far away from the line going in the other direction. So for example, V here is at 0, 3, and it is 1, 2, it's 1, 2 units away from the line. So V prime has to be 1, 2 units away from the line. And that point would be 0, -2. Okay? The interesting one is W. Now W is on the line y equals 1. So to reflect it or to flip it over the line is just a reflection on itself. So this point W, if I flip it over the line, it'll stay on the line. So W will stay at -5, 1 on the line. So this is also W prime. Okay, so I'm going to do one more with you and then I'm going to have you do the last two on your own. Let's look at X prime. Well, we'll look at our original X value, and our original X point is here, and that's 1, 2, 3, 4 away from the line y equals 1. So I'm going to flip it over the line on the opposite side by 4 digits. So 1, 2, 3, 4. So this becomes X prime, and that's at the point -1, 5. Alright, so now I'd like for you to pause the video and reflect these two remaining points over the line y equals 1. So for y prime you should have gotten 4, 0, and z prime you should have gotten 6, 5. If you didn't, ask a partner or raise your hand. Okay, and if you remember from algebra, if you graph the line y equals x, the line y equals x is on the x and y axis. It goes through it evenly. So the line y equals x goes like this, straight through the origin, and it has a slope of 1. So you go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. If you're going to reflect points over the line y equals x, they have to be just like the other lines of reflection. They have to be the same units away from the line. And sometimes that's hard because it's a diagonal line. So they came up with a nice little rule. If you can remember this rule, it'll make it so much easier. If you're reflecting over the line y equals x, then all you have to do is change your original xy values and flip them, just like you would flip them over the line y equals x. So if you have the line y equals x and you have to reflect it, change your x values to y values and your y values to x values. So for example, point A, which they gave us, is -6, 0. So if I reflect over the line y equals x, then I flip my x and y values to be 0, -6. So that would be down here. Now if I'm reflecting over the x-axis, I would do the same thing as before. Here's my x-axis. I would count how many A is away from the x-axis. So here's A, it's actually sitting on the x-axis. So to reflect it or to flip it over the x-axis would leave it exactly in the same place. But to flip it over the y-axis, so here's my y-axis, I have to figure out how far away A is from the y-axis. It's 1, 2, 3, 4, 5, 6 units away from the y-axis. So now I have to flip it over the y-axis by going to the right 1, 2, 3, 4, 5, 6 units. So this is where A prime would be, flipped over the y-axis, and that's 0.60. Okay, so now let's do that again with point B. Point B is over here, and that's at -3, +5. So if I want to reflect it over the x-axis, remember this is my x-axis, so I have to figure out how far away it is from my x-axis. So it is a total of 1, 2, 3, 4, 5. So that means I have to go down 5. 1, 2, 3, 4, 5. So my reflection over the x-axis was at -3, -5. Now flipping it over the y-axis, here's my y-axis. I have to figure out how far away it is from the y-axis, and it's 1, 2, 3 digits away from the y-axis. So I have to flip it over here 1, 2, 3 digits over the y-axis. And then remember the reflection of the line y equals x. I just flip-flop my x and y values so that they read y and x. Alright, I'd like for you to pause the video and try 6 through 8 on your own. Alright, and the answers you should have gotten were 0, -3, 0, 3, 0, -3, -3, 0, etc., etc. There's a possibility that I may have done one wrong, so if that's true, let me know, or if you did it wrong and you don't understand why, just raise your hand or ask a neighbor. Okay, I'd like for you to pause the video and move on to video number 2.